Hi class, my name is Bindu and I'm doing my TeachOne on Stratified Covariate Balancing HAP 823 at George Mason University. This course is taught by Professor Alemi. I'm doing question 1 as my TeachOne and there are 4 questions in question 1. So this is question 1.1. Visually show that Dr. Smith sees a different set of patients than his peer groups. So a tree where the nodes are the diagnosis and the consequence are length of stay within the tree branch, and each branch is drawn proportional to the expected length of stay. This is our original data from the question 1.1. So first of all, I loaded the data in R and performed the following. So from the result from R, we can conclude that Dr. Smith sees a different set of patients than his peer groups. Dr. Smith is 0.52 times less likely to see patients diagnosed with heart failure and the metastatic cancer. So visual display of the data. To visually show the difference between Dr. Smith and the peer group or the other doctor, we need to follow the following steps. To draw a tree where the first node is heart failure and the second node is metastatic cancer. Then calculate the length of stay for each combination. Branch 1, branch 2, branch 3 and branch 4. And then draw these branches proportional to the length of stay. This will make a visual representation of the tree. So I loaded the data in SQL and used the following script to compute the length of stay with 4 different combinations. Branch 1, branch 2, length of stay, branch 3, length of stay, and branch 4, length of stay. So to draw the decision tree, I use the align tool found in the web. You can also draw using the Word or PowerPoint. So here the 2 diagrams is for each doctor, Dr. Smith and his peer group. So first one is for Dr. Smith, and we can see that there are 2 nodes, heart failure and metastatic cancer, and length of each branch is showing the length of stay. So in the first branch, the length of stay count is 2787. Similarly, in the fourth branch, length of stay count is 7622. So we can see that longer the length of stay, the longer the branch will be. So the fourth branch is almost the double in compared to first branch. Similarly, I did for his peer groups. And question 1.2 is asking to balance. I use SQL to balance the data. So select count length of stay as n cases, and I keep this in timetable called cases, and similarly I did for his peer. I keep this in timetable called controls, and then I display the result cases and control. These two are the result from 2 timetable cases and control. For question 1.3 is asking to report the unconfounded impact of Dr. Smith on length of stay using the common odds ratio of having above average length of stay. I also use SQL for this question. Select count length of stay as n cases, and I keep the result into timetable called cases, where care for by Dr. Smith equals to 1. This is the variable for Dr. Smith, and similarly I did for his peer groups, and I keep the result into timetable called control, and match cases with control and calculate the common odds ratio. I use this SQL code to calculate the common odds ratio, and I got the result of 0.950617. For question 1.4 is to report the impact of Dr. Smith on the length of stay using the weighted length of stay. I use the code to calculate the length of stay, and in this case also I keep the data into case timetable called cases, and for his peer group I keep the data into controls. After keeping the data into cases and I use the inner join from cases and control on this variable, and this is the result I got from SQL. And calculate the average impact of Dr. Smith and the peer group after balancing. I use this code to calculate the average impact of Dr. Smith and peer group, and I got the result as shown in the figure here. So we can see that peer group average length of stay is 5.97, whereas for Dr. Smith average length of stay is 3.88. And this concludes my thank you all for watching.